Okay, now we go to another exercise, also from the official exams. This time it's session 2013, the first one. Now we can manipulate. Usually I manipulated this session because the exercise contains questions that we do not need to know, okay, including power, which is the upcoming chapter. That's why when you look at this, it's going to be a very short question because many parts are away, okay, are taken. So we have an electric series circuit is formed as in the adjacent figure, a generator delivering a constant voltage 24 volts, a resistor of resistance R equals 48 ohms, okay, this is a typing mistake, a rheostat D prime of adjustable resistance RH, this is nice, an approach using rheostats. Show applying the law of addition of voltages that the current in the circuit is given by the expression I equals UPN over R, this is nice. Okay, and we need to use the law of addition of voltages, great. We vary the value of RH between two limiting values, 0 and 120, because you know the rheostat changes according to its length, from 0, the least value, to 120, according to the given its limiting, that is the maximum. Okay, the limiting values are the minimum, which is always 0, and the maximum, which is here given to be 120. Calculate the value I1 for RH0, I2 for 120, deduce the role of the rheostat. Okay, let's go and start solving. Part 1, applying the law of addition of voltages, show that the current in the circuit is given by this expression. Okay, we start. The given states that we need to use the law of addition of voltages, right? So we can directly apply it without explaining things. UG, U generator, yes, G is given as G, equals U of D plus U of D prime plus U of K. Okay? By the way, over here, okay, over here, it would be better if you have said UPN equals UPA plus UA. I don't have any point here, okay? So no, I would prefer to use this. If I had another point, I would move from P to A to this point, then from here to here. I need to mention that switch K doesn't take anything, okay? Now, some of you might say, why can't you say from P to A, then from A to N? You are right about that, but in such type of questions, be smart. Always mention that the voltage of the switch is 0, okay? Even if it's not mentioned in the question, always include that. We need to worry about each single grade that you need. So, equals, any zeros first, I can fix K here. UK is 0, U of K is 0, because it's a closed switch, okay? So, if I'm not mistaken, U generator was 24 volts. Or you know what? We need to find that expression. We don't need to go into values. So U, Pn, which is the generator, equals UD plus UD prime. Now, as I'm solving this or checking this, I noticed that the question demands something related to current. How can I pass from voltages to current? So now we can apply Ohm's law on D and D prime, because both are resistors, right? Which state U equals R times I. Okay? Now, UD equals R of D, I of D, and U of D prime equals R of D prime times I of D prime. Okay? Now, both. Okay, first I have the values of the resistances. That's cool. I'm just missing the values of the currents. But current I equals ID prime, because we are in series. In series, current is unique. Okay? In series, okay, current is unique. Therefore, U Pn is equal to R times I plus R H times I. Taking I common factor, R plus RH, hence I can just group ideas together, I equals UPN over R plus RH. And voila, this is what we need to calculate, right? R1, yes, D is given to be of resistance R1, so instead of replacing R, I will add R1 here, okay, and I have the same result. Now, in case you have solved this using a different approach, an important thing you have to keep in mind, you don't need to explain this, but you need to mention that UK is 0. This is an important part, okay? Now, UPN equals UD plus UD prime. This is the law of addition of voltages. It's not that important. Applying Ohm's law on both is very important. Then, using the uniqueness of current is also important. The remaining part is trivial, I think. Okay? Now, whether you want to mention this later, for example, you would reach U equals, replace this in the equation U equal UD plus UD prime, then isolate I, it's also the same. So whether you switch these, the order of them, or not, it's definitely correct. Let's move to the following part. Okay. We vary the value of RH now from 0 to 120. We need to calculate the value of current in each of the two cases. Now this is very simple. Why? Because even if you have a mistake in the previous part, you can directly use the value, right? So RH equals to 0, semicolon, I1 equals UPN, which is 24. Let me write it first as 24, as UPN, sorry. UPN over R1 plus RH, and RH is 0, notice, which is 24 over R1, I think it's 48, yes. I remember because I corrected the ohm beside it. So I1 equals 0.5 ampere. So when the rheostat's voltage is 0 or resistance is 0, the current is 0.5. If you remember, when the rheostat's resistance is 0, then all the voltage is taken by the load. Okay, it's taking the full power or the full voltage. Part 2. Calculate the value when RH is 120. Here I can directly say I2 equals 24 over 48 plus 120, okay, which is 24 over 168, approximately dividing by 24 both, so we have 1 over 7, 1 over 7, which is approximately 0.14 ampere. Okay? That's it. So, notice when the rheostat's resistance is high, the current drops. So what do you notice? What's the role of the rheostat in the circuit? 2, 3. What is the role of the rheostat in the circuit? You can simply say regulate the current, right? It can simply regulate the current, increase or decrease the current, change the current, okay? Anything which has to do with the current is accepted, okay? Now, if you want to go one step further and say regulating the current through the whole circuit and thus regulating the voltage across the load, it's acceptable. But we cannot directly say voltage of the load, because according to the question here, we calculated the currents I1 and I2. Then deduce the role. You must give your comment about the role of the rheostat depending on these two values, on these two parts. Okay? So you can directly say this, then add that the voltage will change. Okay? It's okay. Or you can talk about regulating current and calculate the voltage. You can also calculate the voltage in the load for each case. Then mention that voltage here is less than or more than here. Therefore, the rheostat is regulating voltage. But you cannot directly go to voltage without mentioning or using the currents. Why is that? Because the question is to deduce the rule, not give your own opinion about the rule. Right? Now, part 3. The maximum voltage that resistor D can withstand is 12 volts. Show that the resistor D can be damaged only in one of the two limiting cases. It can be damaged. So here, if you have calculated the voltage in part 3, 2, 3, it's great. If not, I'm given a condition about voltage here. Where is it? 12 volts. So first of all, for I1 equals 0.5 amperes, UD1, which equals R1 times I1, UD1 equals, R1 is given to be 48 times 0.5, so equals 24 volts. And this is the dangerous part. Okay? It's going to be damaged, right? Okay. So here, okay, and for RH equals 120 ohms, I2 equals 0.14 ampere, then voltage U of D2 equals U of D in case 2, or I'll just get rid of this 2 so that it won't give you any confusion, yes? UD becomes 0.14 times 48, times 48, which is approximately 7, okay? 0.14 is 1 over 7. 48 over 7 is around 7, yes? Volt. Okay? 7 volts is less than 12 volts, then it is safe, while for RH equal to 0, D is damaged. Why is that? Because it receives 24 volts, which is greater than 12 volts. Any answer which is close to this is definitely acceptable. You don't need to stick to what I've done here. Okay? You could have given the comment directly here. Once you reach U equal 24 volts, you can directly say, okay, it almost dropped. You can directly say here that it is damaged. Okay? So it's acceptable to do that, or continue till the end. Okay? So this was an exercise, or a portion of the exercise given in an official exam. The change in the official exam is that you are given power here, electric power, not voltage. Okay? That's not that big deal. Okay? I hope you didn't have a problem with this exercise. In this exercise, we reviewed Ohm's law as usual. We focused on the role of a rheostat. Again, we reviewed all ideas. And you notice that in all cases, we used the laws of connections that we talked about in chapter 4. Okay, that's all concerning this part. Now, in the upcoming session, we'll continue and solve another exercise.